So for this problem, they just ask to find the relative minimum and maximum. So those are our extrema, which come from the first derivative. Okay. Now for this function, we're going to have to do the quotient rule because I have an x on top. So remember, your quotient rule is g times f prime minus f times g prime all over g squared. So our derivative here is going to be f prime of x, and remember, f is what's on top, g is always what's on the bottom. So that'll be x minus 2 times f prime derivative of x squared, that's 2x, minus f is x squared, and then the derivative of g is 1 all over x minus 2 squared. Now I want to go ahead and distribute this 2x. So that's going to give me 2x squared minus 4x minus x squared. Sorry, that's an x minus 2, not an x squared. I'm going to go ahead and combine like terms. So 2x squared minus x squared, I'm just going to erase this and rewrite it, is going to give me 1x squared. And then the last thing I'm going to do is factor the numerator. So I can take out an x. So this one's a little different than the last one we did. Okay, so when we're finding our critical numbers, okay, that's what makes the derivative equal to 0 or undefined. So this time I have x's on top. So my critical numbers, I would get 0 here and 4 here. Those are the two x values that make the derivative equal to 0. But then I'm also undefined at x equals 2. Okay, and then I also need to remember that I have a vertical asymptote at x equals 2. Okay, so vertical asymptote means we're undefined there. So we're not going to have a point there. So it cannot be a max, it cannot be a min, and we also have to break up for it in our intervals for increasing and decreasing and concavity if we were doing those. So now in my chart, I'm going to have 3 numbers. So my smallest is 0, then I have 2, then I have 4. Okay, so I'm going to plug in a negative number. I'm going to plug in -1, and notice the bottom is squared, so the bottom is always going to be positive. So I don't have to really worry about that. I just have to worry about the 2 factors on the top. So if I plug in -1, that'll give me a negative times a negative. That'll be negative, that'll be negative. Makes it positive. Then I'm going to plug in 1, so that'll make this positive, that negative. So this means here I'm increasing, here I'm decreasing. I'm going to remind myself that 2 is a vertical asymptote. When I plug in 3, this part will be positive, 3 minus 4, that'll be negative. So I'm still decreasing. And then when I plug in, let's say 5, that's positive, giving me a positive times a positive. Okay. So then we want our relative minimums and maximums. Well, 0, that's going to be a maximum. Because that'll be a high point. I'm going up, then I'm going down, so I'm turning around at 0. 2, I know it's not changing, but 2 can't be a min or max even if we did switch right here because it's a vertical asymptote. But then if I look at 4, I'm going from decreasing to increasing, making that point at 4 a relative minimum. And I know this one doesn't ask for the increasing and decreasing intervals, but let's say they said find the intervals where it's decreasing. That's from 0 to 4, okay? And these are consecutive intervals, but unlike the other one, since we have a vertical asymptote here, you're going to have to put a break in your interval. So anywhere you have a vertical asymptote, if it's increasing along, like on both sides of, or sorry, decreasing on both sides of that vertical asymptote, you have to put a break at 2 because you're undefined there. Now let's look at part of one more question. Okay, so number 6, find the relative extrema. Those are your maxes and mins. That's the first derivative. That would be this equation right here. Okay, this one's very similar to the one we just did. I'm not going to work it out, but I am going to do the point of inflection. So point of inflection, that's the second derivative. Okay, now fortunately they already took the derivative for us, the second derivative. Okay, I'm going to set it equal to 0. This will give me my possible points of inflection. So x equals 0 is going to come from the numerator. That makes the second derivative equal to 0. Okay. And then x equals 2 is going to make it undefined from the bottom. Okay, and this is also, I know they didn't give us the original function, but that will also be a vertical asymptote. Okay, so I'm going to keep in mind I have a vertical asymptote at x equals 2. So let me make my chart. 0 would be my smallest PPOI, 2 would be the biggest. Okay. This time, since the bottom is cubed, it depends what the inside is, whether it's positive or negative, so I have to think about both parts. So over here, I'm going to plug in -1. That'll make the top positive 4. That'll be -3 cubed. A negative to an odd power is going to stay negative. So this part is negative, which means the graph is concave down. Then I'm going to plug in 1. That'll make the numerator a -4. That'll make the bottom -1 cubed, which is going to still be negative. So that's positive. So this is concave up. Okay. I'm going to remind myself that 2 is a vertical asymptote. So even if I change concavity here, it can't be a point of inflection because we're undefined there. So let's plug in 3. That'll make the top -12. That'll make the bottom 3 minus 2, 1. Cubed will be positive. So this is going to be negative, making it concave down. So then my points of inflection is going to be where your concavity changes. So at 0, and yes, the concavity changes at 2, but 2 is a vertical asymptote, meaning g of x is undefined at x equals 2. So that can't be a point of inflection because there is no point there.